1. Noise pollution. While the VTOL helicopter from Tesla is designed to be quieter than traditional helicopters, it will still produce some noise. This could be a concern for people living in areas near airports or helipads. VTOL helicopters are generally quieter than traditional helicopters due to their smaller engines and advanced noise reduction technologies. However, they still produce some noise, which could be a concern for people living in areas near airports or helipads. Professional discovery. Studies have shown that even though VTOL helicopters are significantly quieter than traditional helicopters, they still contribute to noise pollution, especially in densely populated areas. The noise generated by VTOLs can be disruptive to sleep, concentration, and overall well-being. It can also affect wildlife and ecosystems. Mitigation strategies. To minimize noise pollution from VTOL helicopters, several mitigation strategies can be implemented. Location and design. Careful placement of landing pads and helipads away from residential areas can significantly reduce noise exposure. Additionally, designing VTOL helicopters with noise-reducing features, such as acoustic coatings and optimized rotor blades, can further minimize noise emissions. Time restrictions. Implementing time restrictions for VTOL operations, particularly during nighttime hours, can help protect communities from noise disturbances during sensitive periods. Community engagement. Active communication and engagement with communities surrounding VTOL operations can help address concerns and build trust. This involves informing residents about the noise levels, mitigation measures, and procedures for reporting noise complaints. 2. Infrastructure requirements. VTOL helicopters require specialized infrastructure for operations, including landing pads and charging stations. This could pose a challenge in some areas, particularly in rural or underdeveloped regions that may not have the necessary infrastructure in place. Professional discovery. The availability of adequate infrastructure is crucial for the widespread adoption of VTOL helicopters. Establishing a network of landing pads and charging stations in urban and suburban areas will be essential for ensuring seamless operations. However, in rural and underdeveloped regions, the development of such infrastructure may require significant investment and coordination with local communities. Mitigation strategies. To address the infrastructure challenge, several strategies can be adopted. Standardized landing pads. Standardizing the design and dimensions of VTOL landing pads can streamline their construction and facilitate their integration into existing infrastructure. Mobile charging stations. Developing mobile charging stations that can be deployed as needed can provide flexibility in areas with limited permanent charging infrastructure. Public-private partnerships. Collaborating with private companies and organizations, such as airports, helipads, and businesses, can accelerate the deployment of landing pads and charging stations in strategic locations. 3. Safety concerns. VTOL technology is still relatively new, and there are some safety concerns associated with it. For example, there is a risk of accidents during takeoff and landing, as well as during flight in confined spaces. Professional discovery. The novelty of VTOL technology raises concerns about pilot training, maintenance standards, and potential safety hazards. To ensure the safe operation of VTOL helicopters, rigorous training programs for pilots and maintenance personnel will be essential. Additionally, ongoing research and development are needed to identify and mitigate potential safety risks. Mitigation strategies. To enhance safety in VTOL helicopter operations, several measures can be implemented. Pilot certification and training. Implementing stringent pilot certification and training programs, including specialized training for VTOL operations, can significantly improve pilot competency and reduce the risk of accidents. Advanced technology integration. Integrating advanced avionics systems, obstacle avoidance technology, and redundant safety features can further enhance the safety of VTOL operations. Thorough maintenance. Implementing comprehensive maintenance procedures and establishing regular inspections can help identify and address potential safety hazards before they occur. 4. Regulatory hurdles. VTOL helicopters are a relatively new technology, and their unique design and capabilities may require additional regulatory oversight before they can be approved for commercial use. Regulatory bodies will need to thoroughly evaluate the safety, environmental impact, and overall operational suitability of VTOL helicopters before granting them certification for commercial operations. Professional discovery. Regulatory agencies around the world are actively engaged in developing guidelines and regulations for VTOL helicopters. The International Civil Aviation Organization, ICAO, has established a working group on advanced air mobility, ARM, to address the unique challenges posed by VTOLs. This working group is working on developing global standards and recommended practices for VTOL operations. Mitigation strategies. To expedite the regulatory approval process for VTOL helicopters, industry stakeholders can collaborate with regulatory bodies to provide comprehensive data and support for the safety and performance of their VTOL designs. Additionally, active participation in industry forums and working groups can help ensure that regulatory frameworks are developed in a timely and informed manner. 5. Cost effectiveness. The upfront cost of purchasing a VTOL helicopter is expected to be high compared to traditional helicopters. This is primarily due to the complex technology, advanced materials, and specialized manufacturing processes involved in their production. The limited production volume of VTOL helicopters also contributes to their relatively high cost. Professional discovery. Several factors are driving the high cost of VTOL helicopters, including complex technology. VTOL helicopters incorporate sophisticated avionics systems, propulsion systems, and control mechanisms, which demand specialized expertise and high-quality components. Advanced materials. The use of lightweight and durable composite materials in VTOL helicopters enhances their performance but also increases production costs. Limited production volume. The limited production volume of VTOL helicopters due to their nascent market hinders economies of scale and contributes to higher production costs. Mitigation strategies. To address the cost issue, VTOL manufacturers can explore strategies such as increased production volume. As demand for VTOL helicopters grows, economies of scale can be achieved through increased production volume. Component standardization. Standardizing components across different VTOL models can reduce production costs and improve supply chain efficiency. Technological advancements. Continued technological advancements in materials, manufacturing processes, and avionics systems can help reduce costs while maintaining performance standards. 6. Fuel efficiency. VTOL helicopters are powered by electric motors, which offer significantly better fuel efficiency than traditional helicopters that rely on fossil fuels. However, the energy density of batteries currently limits the range and endurance of VTOL helicopters. Professional discovery. Improving the energy density of batteries is crucial for enhancing the fuel efficiency and range of VTOL helicopters. Ongoing research and development in battery technology are focused on developing batteries with higher energy density and longer lifespans. Mitigation strategies. To address the range limitations of VTOL helicopters, several strategies can be employed. Developing new battery technologies. Research and development of next-generation battery technologies with higher energy density and improved power-to-weight ratios can significantly extend the range of VTOL helicopters. Optimizing flight configurations. Optimizing flight configurations, such as airspeed, altitude, and load distribution, can improve fuel efficiency and range without compromising performance. Utilizing hybrid power systems. Hybrid power systems that combine electric motors with small internal combustion engines or fuel cells can bridge the gap between range and performance, allowing VTOL helicopters to operate over longer distances. 7. However, the VTOL helicopter has a major advantage over traditional helicopters in terms of its ability to take off and land in tight spaces, making it ideal for urban environments and emergency situations. Its maneuverability also allows for quick and efficient transportation of personnel and supplies to remote or inaccessible locations. Additionally, the VTOL helicopter's vertical takeoff and landing capabilities eliminate the need for runways or helipads, reducing infrastructure costs and increasing operational flexibility. Despite its range limitations, the VTOL helicopter has the potential to revolutionize the way we approach transportation and emergency response. 8. Battery technology. VTOL helicopters rely on batteries to power their electric motors, making battery technology a critical aspect of the design and operation. The batteries must be able to provide sufficient power for the helicopter's flight operations while also ensuring safety and durability. Professional discovery. Advancements in battery technology are essential for the successful development and widespread adoption of VTOL helicopters. Current battery technologies offer limited energy density, which restricts the range and endurance of VTOL aircraft. Additionally, battery degradation over time can impact performance and safety. Mitigation strategies. To address these challenges, VTOL manufacturers and battery researchers are focusing on developing next-generation battery technologies with higher energy density, longer lifespans, and improved safety features. These advancements will be crucial for enabling VTOL helicopters to operate effectively and safely. Higher energy density. Developing batteries with higher energy density will allow VTOL helicopters to fly longer distances and carry heavier payloads. Extended lifespan. Increasing the lifespan of batteries will reduce operational costs and ensure that VTOL helicopters remain in service for longer periods. Improved safety features. Implementing battery safety features, such as thermal management systems and redundant protection mechanisms, will minimize the risk of fire or explosion. 9. Maintenance requirements. VTOL helicopters are complex aircraft with sophisticated systems, requiring regular maintenance to ensure their continued safe and reliable operation. The maintenance requirements for VTOL helicopters are expected to be higher than those for traditional helicopters due to the unique design and technology involved. Professional discovery. Ongoing research and development in predictive maintenance technologies can help reduce the frequency and cost of maintenance for VTOL helicopters. These technologies use data analytics and machine learning to identify potential issues before they cause problems, allowing for proactive maintenance and preventing breakdowns. Mitigation strategies. To manage maintenance costs and ensure the operational readiness of VTOL helicopters, several strategies can be implemented. Standardized maintenance procedures. Standardizing maintenance procedures and checklists across different VTOL models can improve efficiency and reduce the risk of human error. Remote monitoring and diagnostics. Utilizing remote monitoring and diagnostic tools can provide real-time insights into the health of VTOL systems, allowing for timely interventions and preventive maintenance. Data-driven predictive maintenance. Employing data-driven predictive maintenance techniques can anticipate potential failures before they occur, reducing the need for reactive maintenance and minimizing downtime. 10. Pilot training. Pilots will need to undergo specialized training to fly the VTOL helicopter. This could lead to a shortage of qualified pilots. 11. Security concerns. The VTOL helicopter's ability to take off and land vertically could make it a target for security threats. This could require additional security measures. 12. Impact on traffic. The introduction of VTOL helicopters could lead to increased air traffic congestion, especially in urban areas. This could have implications for noise pollution and safety. 13. Effect on traditional aviation. The VTOL helicopter could disrupt the traditional aviation industry, potentially leading to job losses and economic disruption. 14. Environmental impact. The production and disposal of VTOL helicopters could have environmental impacts, such as resource consumption and pollution. 15. Ethical considerations. The use of VTOL helicopters could raise ethical concerns, such as the potential for increased surveillance and the impact on privacy. Conclusion. While VTOL helicopters offer promising advancements in transportation, they also present unique challenges in terms of noise pollution, infrastructure requirements, and safety concerns. Addressing these challenges through innovative technologies, infrastructure development, and rigorous safety protocols will be crucial for the successful and widespread adoption of VTOL helicopters.